compete at electrodes if it is solution. And we realize that there are three main conditions that determine which one is preferentially discharged. Like when we have NaCl solution, when we have NaCl solution, we have also water, and we are going to have H plus OH minus there. Although instead of the real way it happens is H3O plus. That's how it happens. But for ease, this is how we write it. Now, since these two we migrate towards the anode. This one we go towards the anode, this one we go towards the cathode. So, the cathode or anode will have to select one of each of these. And what determines them, the selection are nature of the electrodes, relative position of ions in the series, and concentration. I will explain each in turn. Now, for the nature of electrodes, we realize that some electrodes, they are not inert in electrolysis. When they are used for electrolysis, instead of the, what do we call it, electrons to go or out of the ions, the electrodes react with ions. And when the electrode reacts with the ions, it trumps every other condition. Because it has said, okay, this is what I'm going for. Either the concentration is high or low, either the position in the series is high or low. I am going for this. So it will react with that ion. And that is later being used in different situations. Now let's look at what is written. Nature of electrodes. Some electrodes are not inert in electrolytic reaction because they have strong affinity for certain ions, and this may influence the ionic discharge. So that is the first thing. So whenever you are looking at any electrolytic reaction, look at it as in which does the electrode have affinity for any of these ions. If it has, that is what will be discharged. If the electrodes do not have affinity for any ion, they are referred to as inert electrodes. E.g. platinum and graphite. And graphite in most cases are inert. Does not mean that all true. They might also come into some electrolytes where they will find ions they will prefer. Now let's look at an example. In electrolysis of NaCl, mercury has affinity for sodium ion. So what we are saying here is this: if sodium chloride solution is being electrolyzed and the electrode is mercury, that is the cathode is mercury, it won't discharge the hydrogen ion. Though under normal circumstances, you should go for the hydrogen. You should go for the sodium ion. And that is how sodium is being extracted. Now let's look at another one. If copper anode is used in electrolysis of CuSO4, the anode goes into solution. Since this gives up their electrons readily than SO2 minus and OH minus. Can you see that? So instead of either working on the OH minus or SO4 2 minus, it will rather go into that solution itself. So this principle is used in purification or extraction of some metals. So you can see, the first thing I look for whenever I want to look at electrolytic reaction, which one will be discharges? Nature of the electrode. Does it have any preference of the ions or not? Now, the second condition is relative positions of ion in the series. You see, I've said it before, when we have them in solution, there will be competition between the water ions and the salt ions. Now, if all other factors are constant, the cation, which is lower in the series, that is this one, you prefer to this one. You prefer to this one, you prefer to this one. Because it will require lesser energy to go into electrolytic reaction than the one that is up. So these ones are very strong. They are ions. So it will require strong energy to remove them from ion to become atom. In the same way, for the anions too, you can see decreasing electronegativity. No, sorry, this one should be increasing electronegativity down. Sorry. So this one should be decreasing electronegativity. So here, we have decreasing electronegativity. Therefore, these ones here will be preferred because these ones, the ones that is higher will remain strong in the solution than the ones that are less electronegativity. So the lesser the electronegativity or the lesser the electropositivity, the more the preference for the ions to be discharged. Think about it. If you have, like, if you dissolve sodium in water, sodium salts, if you dissolve sodium salt in water, you can see we have sodium, we have hydrogen, we have other Cl and OH minus. You can see that the distance between hydrogen and sodium is large in the series. So hydrogen will be preferred unless there is this, preference. There is a kind of preference by the electrode for sodium ion. That's what I was talking about in the previous example. That is, if the electrode has preference for sodium, that's when it will discharge sodium. Either way, but under normal circumstance, it's supposed to go for the one lower in the series. For the anions too, that is the negative ions, it will go for the one of lesser electronegativity, unless there is preference. You understand? For the one that is higher, that's when those ones can be discharged. So, under normal circumstance, unless there is preference for that ion, which is either higher electropositivity or higher electronegativity, it will rarely happen that the ions at the higher position will be discharged. That is what we should know. So in most cases, when we have solution of sodium salt, potassium salt, magnesium salt, hydrogen will be discharged at the cathode. Now for the anion, unless there is preference for the ones higher in the series, that is the only time it will discharge it. Else, if there is solution of the salt that has fluoride, SO4 2 minus, NO3 minus, OH minus will be the one to be handled. You understand? Hydroxide ion will be the one to be handled. So what we are saying in essence is this. If the electrodes are inert, under normal circumstance, when the concentration is normal, or when you have the dilute solution, it will go for the one lower in the series. Hear me? When the electrodes are inert, concentration is dilute or normal, not high. Not high. It will go for the one lower in the series. So that is what this one is talking about. Now let's look at when we have concentrated solution. Now let's look at the effects of concentration. Increasing concentration of a given ion tends to promote its discharge from the solution. So what we are saying is that if the concentration of an ion is increased, it ought to help it to be discharged because it is greater. It can overcrowd the one that is not much in concentration. But the influence of concentration is effective only when the competing ions are closely positioned in electrochemical series, but less important when they are wide apart. I have reiterated this. When the distance on the electrochemical series is high, no matter how concentrated that one in the higher position is, the one in the lower position will be preferred. But when they are close, like 1 or 2 positions apart, the one in the higher position will be selected because the energy is now almost equal to be preferred for discharge. Now let's look at NaCl solution. NaCl contains Na plus, Cl minus as cations and anions respectively. Water contains H plus and hydroxide ion respectively. Now, when they are in this liquid form, we said it. The cations will go to the cathode and the anions will go to the anode. They will now go for competition by the electrodes. In this instance, we are assuming the electrodes are inert. Please, the electrodes are inert. So here, look at it. The concentration of the sodium and chloride ion are high. Please take note. But the concentration of hydrogen and hydroxide are low. Now, at the cathode, sodium and hydrogen ions will go to the cathode. So the concentration is high. Hydrogen is preferred because of the wide distance. I've repeated that. Now look at the anodes. Chloride and the hydroxide ion will go. But chloride ion is discharged because of the closeness. If you look at it, the chloride ion from the hydroxide ion, the distance is maybe 2. So it will go for the chloride ion easily in this instance. So by the time we treat some electrolysis or electrolytic reaction, you will be able to know the effects of concentration in some instances and prevalence of the electrodes. Thank you very much. See you in the next session. And before then, we might treat Faraday's law. Kindly subscribe, share, comment, and like. Follow. Anything you think we should do to promote your advice is highly welcome. Thank you for the support so far. And let others who need to know about this, let them know about it. Thank you so much.